Environmental issues have several dimensions.
The important thing is that the industry wants skills and the competencies.
That is, how can we build ethical, moral citizens?
Multidisciplinary knowledge required in solving complex problems.
The National Education Policy 2020 emphasizes on multidisciplinarity at the higher education level. Today we bring to you a conversation with Dr. Gopalakrishna Joshi, currently the Executive Director at the Karnataka State Higher Education Council, Government of Karnataka. Fondly known as Dr. Joshi for most of us, he in his earlier role was the Dean of Curriculum Innovation and Program Assessment, wherein he experimented with multidisciplinary environment and successfully completed many projects. Today we are honored to have him with us to walk through that memory lane and share with us as to what it takes to create a multidisciplinary environment. Dr. Joshi, it's a pleasure to be with you.
Thank you, Rishi.
So let's begin, sir, by helping us to understand as to what was the need for you to start thinking about establishing a multidisciplinary environment in your institution.
See, when students transit from school education to higher education, college education, they move from closed and supervised environment to open and self-regulated environment. It is the responsibility of education to do hand-holding during this transition. It is in this context that this particular course is introduced at first year level for students doing their undergraduate degree in engineering.
That's wonderful, sir. Could you throw some light on the highlights of the course?
This particular course is co-designed and team taught, meaning the course is designed by 14 teachers from 7 engineering disciplines. And when it comes to delivery, against the traditional practice of one teacher engaging with learners, 4 teachers help learners in the typical classroom settings. That is another important highlight of this course. And we follow PBL pedagogy. When I say PBL, I am referring to project-based learning.
Could you share more details about this course?
This particular course, Engineering Exploration, students when they come to first week of the semester, they form teams of size 4 and each student team picks up a problem from a bouquet of need statements that we offer them. So from this need statement, we ask our students to carve out a problem definition based on their observations of society and life around and then studying the literature. So what do we expect them to do or deliver is a statement of problem in terms of objectives, functions and constraints.
I see.
Look at the beauty here. For the same need statement, 8 to 10 student teams come out with so many number of problem statements. This is against their conventional practice where for a given problem having one unique solution. Now they are coming out with a need statement having multiple problem definitions. From here their directions start changing.
Right.
So one particular student team which has carved out a problem definition, then they get into solution space. We expect these students to come out with at least 4 alternate solutions. Once again, we observe here the difficulties faced by students to come out with alternate solutions. They are all used to solving one problem in the conventionally told way, resulting in unique solution. Now you are expecting them to come out with 4 alternate solutions. And when we saw in the beginning, we were seeing the second, third and fourth solutions were siblings or half brothers or step brothers kind of situations. So that's where we introduced morphological charts by changing context, by changing forms, how you can bring in alternate solutions, and how we can provoke students to innovate and come out with alternate solutions. It is a wonderful challenge, but I think that is the way we must promote innovation in classroom settings.
Absolutely.
So, having come out with 4 alternate solutions, the next step is to pick up the best one. And this choice of best one also has to be objectively decided. It is not based on gut and intuition.
Right.
So that's where we introduce them to pairwise comparison and multi-criteria decision making. So how do they arrive at scientifically what is best in the context? They prioritize the objectives,
Right.
and then they make the scores, and based on those scores, they arrive at solution.
Wonderful.
So having chosen the best concept, best concept, now they have to do detailed designing.
Right.
When I say detailed designing, I am referring to coming out with product architecture. When we expect them to come out with product architecture, so that becomes the basis for realizing the product.
Right.
From there, they enter into prototyping facilities with these things. And then that is where once again we've introduced few concepts from agile practices, agile project management practices. Students work in sprints, and then they get exposed to testing, unit testing, regression testing, all these things. While doing, they learn all these things just in time, just in time. And at the end, they come out with the prototype, and we celebrate their success in the form of an exhibition on the last day of every semester.
Wow.
Where we expect students to learn from others, which is also an important part of learning.
Sir, you have shared some of these highlights, and each one of them, I'm sure, are very crucial to establishing a multidisciplinary environment. Now, with all this, what kind of a learning outcome would a course like this have?
See, this particular course, which is named as Engineering Exploration, it is a 3-credit core course. And at the end of the course, the students are expected to explain the engineering problem solving. They should know multidisciplinary skills required in engineering problem solving. They should have a good understanding of engineering design process. Importance of ethics and sustainability in engineering practice. Teamwork and collaboration is another important aspect we want students to develop appreciation for. These are the outcomes of this particular course.
Sir, of these, let me begin by asking about the project-based learning pedagogy. We've all heard so much about PBL. Here is a place where you have tried it out, and that too successfully. Could you share few more details on this?
In fact, through this I can tell you the whole story of a particular delivery. You know, typically students form their teams, and when I refer to teams, it is typically a team of size 4. And there is a bouquet of problems, and they pick up a problem which they are supposed to solve working in that team in the entire semester. In the process, students learn what is engineering design process, and since the solution that typically students arrive at for the given problem is a mechatronic system, we have brought in systems thinking here. sensing, actuation and control, these three dimensions through which students appreciate the need for multiple engineering disciplinary knowledge and integration of that to arrive at solution. So, this is what happens there. Another aspect of this particular course that you have to know is that we want all our students to successfully complete designing the solution and giving us the prototype. This means that we have to ensure students' progress, which is done through introducing intermediate reviews, which is what I refer to as formative assessment. In fact, this entire course, there is no 3 hours written examination at all, which is the conventional practice.
Wonderful, sir. So you also explained as to how, as part of project-based learning pedagogy, there is also formative assessment, and that design goes in hand in realizing the learning outcomes. There's another point that you made about teamwork and collaboration. We all again know that that's something very, very crucial, but very difficult to get done. What were your experiences? How were you able to get the faculty to work in such large teams with the same goals in such a collaborative manner?
See, when it comes to faculty members coming from multiple engineering disciplines, through shared vision and commitment, we were able to bring in collaboration. We were also lucky in that sense. We got very good committed team of faculty members. And when it comes to students, I would like to differentiate between cooperation and collaboration. So, what we have brought in is cooperative learning principles, wherein by introducing interdependency among team members in terms of goals, in terms of resource sharing, students have to understand their responsibilities and work cooperating with the remaining team members. So, that is where they start appreciating working in teams, and they also learn the nuances of working in teams.
Lots of insights for all of us, but I'm sure what we can learn more from is in terms of what were the challenges that you faced, not only in designing it, but after that implementing it. And since we also know that it was implemented successfully, if you could throw some light on the challenges, it would be very useful for all of us listening to you.
One of the major challenge was, we all decided to come together, but then we brought in disciplinary knowledge. But then finding solution for a given problem requires working in multidisciplinary teams and an appreciation for those things.
Right.
This was one of the difficult things to be accomplished. So, when I said about this, what I am referring to is some common understanding in terms of basic engineering concepts and practices was one of the major challenge we had to work on. Second was pedagogical and technological awareness in delivering a project-based learning course was another important aspect which we had to work on.
I see.
Then third aspect was reviewing project works that students do, which I referred to during my assessments, focus on formative assessments.
Right.
This is where the challenge was, all teachers were used to reviewing as individuals, but then now we brought in multiple teachers coming together and doing team reviewing.
Right.
Team reviewing, and that was another aspect which required openness among teachers to accept each other's views. I would like to tell you one more thing with respect to assessment. In addition to teachers, we also brought in self-assessment and peer assessment as part of these assessment practices. That reduced, to some extent, the burden on teachers.
Wonderful.
This is with respect to one of the challenge from teacher's perspective. Then another perspective is whenever you have a course which follows project-based learning pedagogy, these pedagogies, they are resource hungry. When I say resource hungry, they need more space, they need more components, resources. You will have to work on providing these resources.
Right.
And the learning environment that you design should promote collaboration. That is another perspective which we shouldn't miss.
Right.
So these were some of the challenges that we came across, and we used all stakeholders, including alums of our course, in finding solutions to most of these problems.
You've been able to give us very good details about the course. If this has to be scaled up, what according to you are the key steps?
Rishi, as I believe, any such experience or learning experience that we create, if you want the learnings to be reinforced, we will have to repeat them on multiple occasions. So there are several possibilities that exist here. One such possibility is, in addition to project-based learning, you know, there is something called community-based learning or service learning as a pedagogy that can also be brought into our curriculum, undergraduate curriculum, which is a great way of solving problems around using multidisciplinary skills. And another approach that I strongly believe in is, at every year we must introduce a course, a project course which encourages or which gives a scope for learnings across courses. How do we integrate them in the context of solving a problem? You can also have hackathons. You can also have inter-institute project competitions, cutting across the country barriers.
Right.
These are all relevant and needed in today's context, in terms of not just exposing people to multidisciplinary learning, they also give us multicultural learning experience.
Thank you so much. This conversation has been a learning personally for me as well, and I'm sure everyone who watches this will have lots to take away from. Thank you once again for joining us for this conversation, Dr. Gopalakrishna Joshi.
Thank you, Rishi.